In this video, we're going to talk about what's the deal with algebra tiles. Now, I've got a few algebra tiles on my whiteboard here, so I'm going to do a quick introduction first, and then we're going to show how to use them both to factor and for completing the square. They're also very useful for polynomial arithmetic. You know, adding and subtracting and multiplying and dividing polynomials. So they are a visual tool to help you sort of see everything that's going on here so that this isn't just some abstract concept using numbers in your head. You can actually see what this all looks like. Onto the tiles themselves. The smallest black tile here on the far right has a length of 1 and a width of 1. Therefore, it has an area of 1. Now, this sort of larger one here, this rectangle, still has a width of 1, but its length is x. Alright, now I want to mention, it looks kind of like, in our case, that our x here is about 1, 2, 3, maybe 3.5, right? But we can't make that assumption. That x is a variable. Not only do we not know what it is, but it could change. So what we're not allowed to do is we're not allowed to line up these little 1 sides with these larger x sides. We can't line these up because we don't know how many of these it would take to make x. You can only line them up with matching sides. Okay, so if this one is x by 1, then its area is x. And as many of you have probably already figured out by now, this large square is x length and x width, so its area is x squared. Now the red tiles are exactly the same, except instead of representing 1, the smallest block represents -1, negative x, and negative x squared. With these 6 blocks, we can represent any quadratic polynomial and physically show how it can factor or how the square can be completed. What's that? You want examples? Fantastic. Let's do some examples. Alright, here we have f of x equals x squared plus 8x plus 15. And we are going to use algebra tiles to factor it and to complete the square. To start with, I'm going to go ahead and come up with an x squared and 8 x's and 15 1's. Okay, so as you can see, I have filled up both sides of my example problem with x squared plus 8x plus 15. There are two fundamentally different things that we're doing here, but they are similar. When factoring, we want to arrange the tiles in a perfect rectangle so that we can measure the length and width of that rectangle and come up with a product for the area instead of a sum. Now when completing the square, we're doing something a little bit different. When completing the square, we are arranging our tiles into a perfect square, even if we have to maybe use more of the units than we have. And specifically when I talk about units, I'm talking about these. Even if we have to add or remove those units, we need to make a perfect square. So on the factoring side, I want to use every single one of my blocks to make a rectangle. Alright, well I have 15 of these unit blocks here. So I need to figure out a way to make sure I have 15 spaces for unit blocks. Alright, so I'm going to move this x out of the way. I usually put the x squared in the upper left corner. You can put it in the lower right or basically wherever you want. Now, again, there is a very large temptation to try to arrange these so that the 1 side and the x side are meeting. But we can't do that because, once again, we don't know exactly how long that x side is. We don't know how many of these it would take to make up that x side. So you can only link x sides with x sides. And once you have those two x's there, well now you see there's a space for that square to fit, making a rectangle. Now this particular rectangle would be x plus 1 times x plus 1, better known as x squared plus 2x plus 1, right? But we have to use all of our blocks, so let's have a look. How are we going to arrange these x's so that there are 15 spots? Well, I know that I'm going to end up making a little rectangle down here of units, right, of little ones. So I could instead recognize that if I have a length of 3 here, and a width of 5, see, I've got 3 here and I've got 5 here, then that should be exactly enough for me to put 15 of them in. Whoops, looks like I accidentally drew one too many, which means I accidentally drew one too many on this side as well. As you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, our answer to x squared plus 8x plus 15 is equal to x plus 3 times x plus 5. So what we've done is we've taken our x squared and our 8x's and our 15 little ones, and we've created a rectangle that is x plus 3 width and x plus 5 length. So the area, x squared plus 8x plus 15, can also be expressed as x plus 3 times x plus 5. And again, if you don't believe me, or if you ever feel like you have the slightest doubt in your answer whatsoever, you should multiply those back out and see that it is what it is. So that is factoring. Now we're going to do this one more time with completing the square, which again is somewhat similar, but a definitely different process. So I am still going to start by putting the x squared in the upper left. But this time, I am committed to making a square, not just any old rectangle. I can't put 3x's out here and 5x's down here, because that clearly doesn't make a square. Because we have 8x's, we are bound to put 4 of them up here and 4 of them down here. So once again, we can use our unit tiles to fill in the rest. But oh no, we don't have enough blocks to make a full square. We only have 15, we need 16. Okay, so what we're essentially going to do is we're going to borrow a block. Think of it like debt, okay? I can make a new block as long as I also make a negative block to go with it. Because those two blocks, that +1 block and that -1 block, they cancel each other out, right? So long as I create them both at the same time, I haven't actually affected the balance at all. So now I have just enough blocks to fill in my square, and this -1 is just going to kind of hang out here, very sad and lonely. So another expression of our equation is x plus 4 times x plus 4 minus 1. So there's one example of how to use algebra tiles both for factoring and for completing the square. Now this video is starting to run a little bit long, so I'm going to go ahead and leave it at that for the time being, and I will do 2 more examples in the next one.